So in this question, we have this thin air-shaped construction, and we're trying to find the center of mass of this object. We have our origin over here, and this is the reference point we'll use. So at first, this looks like a very strange object, but the question gives us 3 points, which is CMA, CMB, and CM. And this is a hint that we should be looking for these 3 parts separately. So this horizontal leg, the question even draws this line for us to tell us how to separate these 2 parts. And then we have this vertical leg. So what we really should do is to think of these 2 as separate parts, find their own center of mass, CMA and CMB, and then to try to find the center of mass of these 2 small center of mass. So there are 2 steps here. Let's first try to figure out the center of mass of this top object. And to do that, we need to first find the mass of it. So the mass of A. And let's say to find that, we need to assume that the whole object has a mass of big M. And since this burst has the equal width throughout, everything is in proportion. So like its weight is proportional to the length. So right now we know that the total length is 2.06 meter plus 1.408 meter. So the mass of this part would just be plus 1.48, 2.06 big M. So this is just like the ratio of this small m in terms of big M. And that gives us around 0.5819 big M. And that's for this part, MA. And same for this part. MB is 1.48 over 2.06 plus 1.48 big M. Or you can just say it's big M minus MA. So it's 0.4181 M. So that's the mass of MA and MB. And then let's look at the position of it. For MA, we have this distance is just half of 2.06. So we have XA equals 1.03 meter. What about Y? This is 0.2. So YA equals 0.1 meter. Same for MB, but MB, the center of mass, is around here. So we know this is 2.06 and this is 0.2, meaning this is 0.1. So we are looking for this distance. So XB equals 2.06 minus half of 0.2 meter, which is 1.96 meter. So this is just pure geometry. And what about the Y? For Y, this is Y equals 0, and this is just half of 1.48. So YB equals negative half of 1.48 meter, which is negative 0.74 meter. And to find the ultimate center of mass, we just find the center of mass of CMA and CMB. So we have the x-axis equals 0.5819 big M times 1.03 meter. So that's the contribution of this horizontal leg. And then for the vertical leg, we have 0.4181 times 1.96 meter. And this is also big M. And then we have big M as denominator to cancel the big M in the numerator. This gives us 1.42 meter. And we do the same for Y. It is 0.5819 big M times 0.1 meter plus 0.4181 big meter times minus 0.74 meter. Again, over big M. And this gives us negative 0.25 meter. So this number we end up getting is this is equal to 0.25 1.25 meter, and this equals to 1.42 meter. And that is the position of the center of mass for this configuration.